So we'd like to talk about how energy is transferred throughout the atmosphere. And you have three ways that interact with the atmosphere. That's conduction, convection, and advection. And then we have the kind of special case that is radiation, and we'll get into that in a little bit. But first we should start by talking about conduction. It is probably the simplest way of transferring energy. It's energy transfer through contact. So if you've ever touched a warm stove, the warm stove provides energy to your hand. It can cause burning. I don't recommend doing that, but that is a form of conduction. So that tells you that conduction requires stuff. It requires contact. And different substances are better at conduction than others. Metals tend to be very good conductors. Silver in particular, copper, all very good conductors. On the other hand, there are very poor conductors. Wood, still air, very poor conductors, which is very good to know because still air is not going to conduct energy particularly effective. It's going to insulate whatever's surrounding it, whatever it's surrounding. So if conduction isn't very useful for the air, there have to be other ways to transfer energy in the atmosphere. And that brings us to convection, which is the vertical transport of energy. So you have conduction happening right at the surface that's heated up. It's heating up that air. That air becomes less dense and starts to rise. Once it starts rising, that rising motion is convection. So now it's mixing hot air throughout the atmosphere, creating thermals. This is also how a lava lamp works. So there's another option. So once you've mixed the atmosphere, you've got more heat away from the surface, but there's horizontal movement of energy, and that's advection. So this may not be a term you've heard before, but all it is horizontal transport of anything in the atmosphere. Today we're talking about energy transfer or heat transfer, so it's energy advection. You can advect anything. You can advect cold air. Cold air blowing into an area, cooling it down, would be considered cold air advection. You could have warm air advected to an area. So now we'll get to the special case that is radiation. So it's an electromagnetic energy source. So it can propagate without any medium. So it doesn't need the atmosphere. This is how the sun's energy gets to the earth and warms us up. It's transported through space, so it doesn't require that medium. And when interacting with matter and with a medium, radiation will either be absorbed, reflected, transmitted, or scattered. Now, radiation comes in a lot of different forms. Lower energy waves, like radio waves, television waves, and higher energy waves, like ultraviolet waves, and X-rays. You can see that visible light is relatively high energy, which means we can't see things unless they're fairly hot. They have to be very warm for us to be able to see them.